Today we're going to be taking a look at solving quadratic equations. Today it'll be algebraically. That is, by manipulating the equation in order to be able to get to our solution. So you see a problem up here right now that we're going to be using as our first example. So of course be taking notes as we go through this. All right, so if I want to be able to solve this equation, you notice I got a couple things that are kind of in the way of it being solved. One is the fact that I have this squared here, because to solve it means the x is just an x, it's not an x squared. And I also have this minus 1 sitting here as well that's in the way of the x being by itself. So I need to be able to get rid of both of those. Now when doing this, think about the order of operations. Remember PEMDAS. So parentheses, exponents, multiplication and division, and then addition and subtraction. When you are solving like this, what it tells you is to go backwards through the order of operations. So since solving is undoing, you go backwards through this. So that means the very first thing I want to do is get rid of the addition and subtraction in this problem. Now there's no multiplication or division. And so after I get rid of the addition and subtraction in this one, I'm going to then get rid of the exponent. And then I'll have what x equals. So that's kind of my plan as I jump into this. So first up, the addition and subtraction that I need to get rid of is this minus 1. The opposite of subtracting 1 is adding 1. So we're going to add 1 to both sides of our equation, which then just leaves us with x squared equals 9. Now I can get rid of the exponent. Now the opposite of squaring something is square rooting it. So I'm going to take the square root of both sides of this equation. Notice how I'm showing the work there. Make sure, of course, you're getting that work shown on your own paper as well, because being careful about how we show this is going to be important. All right, so I take the square root of both sides. Now, the whole idea of taking the square root is that the square root of x squared is just x. It cancels that squared out. It undoes it. And so that's going to be what leaves us with the x. And so then I just have to do the square root of 9. And the square root of 9, of course, is 3. So this is our basic method for this. Although, as you're going to see, there is going to be one additional wrinkle to this process. One new little trick we're going to add into your toolbox today. And to see what that is, I'm going to take you back to a way that you've actually solved an equation like this before, by graphing. So if I want to solve this equation by graphing, remember what I'm going to be doing is I'm going to be graphing y equals the left side of the equation and y equals the right side of the equation. So first thing I'm going to do then is I'm going to graph y equals x squared minus 1. And then I'll graph y equals 8. Now that I've graphed those, I can look for my solutions. And notice the parabola crosses the line in two different places. It crosses at x equals negative 3 and x equals 3. Now, the tricky thing, though, is that when we solved this algebraically a minute ago, we only found x equals 3 as our answer. So we found this, but we did not find the other one. We did not find the x equals negative 3. And we need to. These methods should match up. They should give us the exact same thing. That's one of the cool things about math, is that no matter how you do it, you should still get the same answer. Well, there's an additional little rule that we need to have in here. So this one is also worth adding into your notes, so you might want to pause the video so you can get this written down. When taking the square root of both sides of an equation, we must account for both the positive and negative square root. Now, what's that mean in terms of the work that we show there? What we end up putting in is we put in that plus or minus symbol. So when we introduce the square root into the process, we have to write that plus or minus in front of it. Now, if the square root was part of the original problem, we don't have to worry about it. This is only when we put the square root into the process as part of the solution. And so we got that plus or minus in front of the 3 here, which means that x equals 3 and negative 3, both. And so this is our actual final solution. So it's fairly straightforward, except for this one little wrinkle that we do need to remember as we go, where if I take the square root of both sides, I have to have a positive and a negative version of that answer. Make sure you have this entire first problem written down correctly on your paper, and then we'll move on and practice this process with a few more. All right, so this is our next problem to solve. So again, take notes as we go through it. So the first thing I want to do here is I want to figure out what order I'm going to be doing things in. Just kind of get a general idea about how I'm going to approach it. And once again, I'm going backwards through the order of operations since I am solving it, that is undoing the equation. So the first thing I want to do is I want to find any addition or subtraction that I want to undo first. Notice that means the plus 7. So that's the very first thing I'm going to do. Then I would look for any multiplication and division that I would need to undo. And I actually do have some multiplication and division in the original problem. That's the 5 right there. So I'm going to be getting rid of that after I get rid of the 7. And then the very last thing we're going to do is we're going to deal with any exponents. And yes, there is an exponent here. That's the squared. So I'm first going to get rid of the addition subtraction, then the multiplication division, then the exponent. So let's go ahead and jump in and begin that process. So in order to get rid of the plus 7 here, which is the first thing I've decided I'm going to be doing, the opposite of adding 7 is subtracting 7. So I subtract 7 from both sides. Next up, remember, was getting rid of the multiplication, the 5. So right now, this is 5 times x squared. I want to undo that multiplication, so that means I'm going to need to divide both sides by 5. Now I just have x squared equals 9. I still need to get the x by itself, which means getting rid of the squared. And remember, the opposite of squaring something is square rooting it. So I'm going to take the square root of both sides. But when I do so, notice the big thing that you got to remember here. That plus or minus. When I include that square root symbol, I have to also include the plus or minus in front of it. And so that means the square root of 9 is 3, therefore our answers are 3 and negative 3. Now, you might be wondering, why do we have to include the plus or minus? Well, let's say I was checking my solutions here. Let's actually just check it with something very simple. Let's check it with just that part there. What's 3 squared? Well, 3 squared is 9, right? So that one checks out. What is negative 3 squared? Well, remember, anytime you square a negative, you're doing a negative times a negative, which is also positive. Therefore, that also equals 9. So we have to include that plus or minus because it's allowing for the fact that squaring a number always makes it positive. So we have to account for the fact that the original number could have been positive or negative. So that's why we got to include that plus or minus in there. All right, now make sure you've written down this problem correctly and that you've got the basic idea down here before we go on to our next problem. So if you need to pause the video, you can. Now we head on to our next problem. Now this one looks a little bit trickier because notice we do have x squared on both sides of the equation. What does that really change? Not much, really. Just like when we're solving other equations that you've solved in the past, if we have x on both sides of the equation, the first thing you want to do is move them both over to the same side of the equation. Now, as I take a look at this one, I could move either the 2x squared or I could move the x squared. But I'm going to choose to move the x squared over to the left side, only because I'm kind of thinking ahead and thinking, well, that'll leave me with a positive x squared, which will probably be a little bit easier than a negative. But either one technically would work. It's just I prefer to keep things positive. So I'm going to subtract x squared from both sides in order to move that over. Now I have x squared minus 7 equals negative 3. Now before I continue and finish this one out, at this point now looks like the type of problem that we've already done together here. So what I'd like you to do is maybe pause the video here, finish solving this out on your own, and then resume the video to see the work that I end up doing in order to solve it. All right, so in order to be able to finish solving it from here, I want to get rid of that minus 7. So I'm going to add 7 to both sides. I now have x squared equals 4, so I have to get rid of the squared. The opposite of squaring it is square rooting it. And remember, when we introduce that square root symbol, we also introduce the plus or minus. Therefore, x here can equal 2 or negative 2. Both of those are solutions, and yes, we would include both of them. Make sure you have all that work correct on your paper, and then we'll move on and we'll do one last problem here together in a moment. All right, now this one's our last problem. Just like on the last one, I'd like you to go ahead and write this one down and work it out before we do it together. So go ahead and pause the video now and work it through and resume as soon as you have that actually done. All right, so now let's go ahead and solve it through. The first thing I want to do is get rid of any addition or subtraction, which means getting rid of the minus 7. The opposite of subtracting 7 is adding 7. So we add 7 to both sides, which gives us 4x squared equals 32. I now need to get rid of the multiplication by 4. So that means dividing both sides by that 4. I now have x squared equals 8. Now I can get rid of the squared by square rooting both sides. Remember the plus or minus when you do that. All right, now I can go ahead and do that calculation. But when I do that in this case, I end up with a decimal. And if you were doing this one on your own, you might well have said, uh-oh, what did I do wrong? Because I just got a decimal. Well, one of the advantages of this method of being able to solve these algebraically instead of graphically is, one, it can be a little faster, but two, when we don't end up with nice, pretty whole numbers as our answers, we can still figure out what the answers are. If you were trying to solve this one by graphing, you wouldn't be able to tell what the solution was because it'd be off in the middle of nowhere. You know, it's at this decimal. But by being able to do this algebraically, we can figure it out exactly. So when we do the square root of 8 on our calculator, we get this number of 2.8284, and it goes on and on. It goes forever. I just wrote down some of the decimals that were showing on my calculator there. So what do we do with this? Well, if you are doing this on a homework problem, it would tell you what to round to. Now, I'm going to go ahead and assume that this problem is going to tell us to round to the nearest hundredth. Mostly because it's very typical that we'll go out to the hundredth place. Remember, the hundredth is 2 decimal places. So that would mean I'd be taking it out to this decimal place right here. Yes, rounding matters. So that's a 2, but then the next digit there is an 8. Since that's an 8, that tells me I'm going to round the 2 up. So I'm going to call this 2.83. And remember, the plus or minus means there's both a positive and a negative version. So my answers here, if I were doing this on, for instance, WAMAP, I would type in 2.83, comma, negative 2.83. And no, the order doesn't matter. If you typed in negative 2.83 and then 2.83, that would be the same thing. So this is how we do it. Now, one other little detail here, since it does come up in the work, you see this symbol right here, the kind of wavy equal sign. Anytime you see that, that means approximately equal. It tells us that as we look back at this later that we did a little bit of rounding there. Why did I not include it in this line? Because I put these 3 dots at the end, which said this decimal just keeps on going. I haven't written down all of it, but it does equal this big long decimal that keeps on going. So a couple little subtle details there for you to be aware of, but of course the biggest thing is just the mathematical process about how we came to those numbers. All right, with that, you should be good to go ahead and now work on your assignment.